this section is really definition heavy. There's a lot of new things to learn about polynomials. And the next thing that we're going to learn is zeros of polynomial functions. Zeros are also called roots, which are also called solutions, like solutions to the equation, or x-intercepts. This is where the function crosses the x-axis. And again, we're talking about zeros of polynomials. The total number of zeros is equal to the degree of the polynomial. But this includes repeated zeros and also imaginary zeros. The multiplicities, our next definition here. Multiplicities, this is how many times you find the x value as an x-intercept or root or zero or solution to the polynomial. In factor form, the multiplicities tend to be the exponents on the factors. The behavior of the graph at the zero, this is different than the end behavior. Behavior of the graph at the zero depends on the zero's multiplicity, which we call k. If k is even, so if the exponent is even, or the multiplicity is even, the function will touch the x-axis at r and then turn back around. So touch and turn. Some people call this a bounce. If k is odd, the function will cross the x-axis at r, your root r, okay? And if k is greater than 1, the function will tend to flatten near r. I know this is a lot. Let's do a couple of examples. Okay, so number 3. We have this polynomial function. We need to determine everything that's going on. First, before we even look at part A, B, C, etc., let's determine if we have standard form or factored form. Because we see parentheses, we have factored form. So part A, for the degree, because it's factored form, we need to add the exponents. Remember, exponents are the multiplicities, and we'll come back to that again. Here, we would need to add 3, 2, and the imaginary 1 on the x plus 5. So 3 plus 2 plus 1 gets us 6. The degree of our factored form is 6. The number of x-intercepts is the same as the degree. So our number of x-intercepts is also going to be 6. End behavior of the function. Remember, end behavior is our arms. First thing we need to find is our degree, which we said was 6. Think to yourself, is 6 even or odd? Because it's divisible by 2, it's even. Remember, when you have an even degree, the arms are the same. After you find the degree, we need the leading coefficient. Since all of the x's in the parentheses have a leading or have a 1 as their coefficient, we're going to concentrate on the number out front. So our leading coefficient A is 4, which in this case is positive. Since it's positive, we're going to end on the right on a positive, end on a positive note, which means the right side goes up. If we have these two things, we can draw our little diagram and write our end behavior. Because the arms, technical difficulties. Because the arms are the same, right side goes up. So right side going up. Left side has to do the same because it's even, which means that we rise left and rise right. That little weird E with the dots is just my and. Next, we need to find all zeros and their multiplicities. Remember, 0 is the same thing as an x-intercept as a root as a solution. To find an x-intercept, we set our equation equal to 0. And then we solve. So here we would take 4x cubed times x minus 1 squared times x plus 5, set it equal to 0. Because it is in factored form, we can use the zero factor property, which means that we can set each of these equal to 0. We would have 4 equal to 0, because it's a factor, x cubed equal to 0, x minus 1 squared equal to 0, and x plus 5 equal to 0. 4 is never going to equal 0. We don't care about it. We move on. For x cubed equal to 0, we would have the cube root of both sides if you want to get technical. And here, we would get x equal to 0. Because on the left-hand side, the cubes cancel and the cube root of 0 is 0. When we look at the x cubed equal to 0, we really didn't need the cube. We just needed the x by itself equal to 0. In our next one, the x minus 1 quantity squared equal to 0, I could take the square root of both sides, just like I did on the last one. And I would have x minus 1, because of the square root and the square cancel each other out. Square root of 0 is 0. There is no positive or negative 0. And we get x equal to 1, which gives us x minus 1 equal to 0 gets us x equal to 1. If you notice, I didn't have to go through all of the square root of both sides if I could notice that I just needed what was inside the parenthesis. If I just needed the x. My last one, I move the 5 to the right. I find out that x is equal to negative 5. From here, we can find their multiplicities. We found each of the zeros. Now we need to find their multiplicities. Multiplicity is how many times they show up. And remember, if it's in factored form polynomial, most of the times it's their exponent. So here, for x equals 0, he has multiplicity of 3. His exponent was 3. For the x minus 1 quantity squared, where we got the x equal to 1, he has a multiplicity of 2 because that was his exponent. And remember, our x plus 5 actually came from parentheses, x plus 5. We got x equal to 5, negative 5. Remember, if you don't see an exponent there, it's the imaginary 1, which means our multiplicity for x equal to negative 5 is 1. Next step, we need to determine the behavior of the graph at the zeros. We have two behaviors. We're either going to touch and turn, or we're going to cross. Touch and turn is when you have an even multiplicity. You cross when you have an odd multiplicity. So if we look back at our multiplicities, we can see that, give me just a second, the pen I was working with, need a different color. Our 3 is odd, 2 is even, and 1 is odd. But you're going to keep in mind that we are not going to write the multiplicities. We're going to write the zeros because it was the behavior at each of the zeros. Because x equal to 0 has an odd multiplicity, he is going to go with the cross. Odd multiplicity, we cross at x equal to 0. I don't care that 0 is odd. I don't care that 0 is even by itself. I care that its multiplicity is odd. For x equal to 1, he has an even multiplicity of 2, which means x equal to 1 is going to touch and turn. It's going to have that bounce effect. And for x equal to negative 5, he had an odd multiplicity, which means we are going to cross at x equal to negative 5. Remember to find a y-intercept. You plug in x equal to 0 and solve or simplify if you want to look at it that way. Okay. So plugging into our function, taking the original function, this f of x equals, coming all the way back up here, or if you did write it down in part D, we would have 4 times, instead of x cubed, we'll do 0 cubed times 0 minus 1 squared times 0 plus 5. You can plug this into your calculator all at once if you would like. Or you can do it in steps. We would have 4 times 0 cubed times negative 1 squared times 5. You should get out 0 because of that 0 cubed out front. If I want this as an ordered pair, I would have 0, 0 because I plugged in 0 for x, got out 0 for y. But if I just want the value for the y-intercept, I have 0.